Okay, so here is going to be a short video that can help you remember how to write equations for straight lines if you're just given 2 points. I want to remind you that no matter what, when you are trying to write an equation for any linear function, the very first thing that you're always going to start with is always going to be finding slope, and you are going to need to be able to identify what your x2, y2, x1, y1 points are in order to do that. If I'm given 2 points, I just randomly choose one of them to be point 1, and when I do that, I'm going to make the point 1 that has my x and my y be point 1 with x1 and y1. The other point then, by default, is point 2, and that's going to have my x2 and y2. And then I just take those values, the x1, y1, and x2, y2, and plug them into my slope formula and just calculate slope. So if I put in my slope m, and it's equal to my y2 minus my y1, all divided by my x2 minus my x1, it will actually just calculate slope for me. 9 minus 5 is 4, 4 minus 2 is 2, and that is going to end up being a slope of 2. Once I have a slope that I just found, and I have some magical x1, y1 point that's been already labeled out for me, the very next step that I'm going to use is I'm going to go straight into point slope form because I have a point and a slope to use. So I will just take the values that I already know and drop them in. And that is the equation for a straight line. So y minus my y1 value is going to end up equaling m times x minus my x1 value, and that is an equation for a straight line. For the purposes of this video, I'm going to take it to the next level and the next level. So we're going to actually convert what we have here into our next version of a straight line, which is slope-intercept form. In slope-intercept form, I have y equals mx plus b. And if I have y equals mx plus b, that means y is solved for. And that's how I get to the next one. I'm going to solve for y. But just like I would normally do, in order to solve, I'm going to simplify first. I'm going to get rid of my parentheses by doing the distributive property. And I will continue to get y by itself by undoing the math happening to it and undoing PEMDAS. I will add a 5 to both sides to undo the subtraction that's there. Now I'm in slope-intercept form. This is the form that most of you are all comfortable with, but there's another form yet that I want you to also be able to get to, and that is the last one on the list here. That is standard form. In order to get standard form set up, I need to have my ax and my by term on the same side of the equal sign, and it's got to equal some constant value. And so what I'm going to do to accomplish that is I'm going to move my x value to the same side as my y value. When I do this, it'll cancel out from the right side. I'll still have a negative 2x on the left side. I'll still have a positive y on the right side. It'll still be equal to 1. I just moved that 2x over. If I'm truly in standard form, though, I can't have my very first term, the a term, be a negative. So this value right here cannot be negative. What I'm going to do to change that is I'm going to take my whole equation and I'm going to multiply it by a negative 1. What it'll do is it will change the very first term, but it won't really change the relationship between the x and the y's that are there because they're both getting hit by that negative 1. So what it'll do is it'll change it all to a positive 2x, but then you'll have your minus y, and it'll be equal to a minus 1, and that's okay. I just don't want my very first term to be a negative when I'm in standard form. And this one here is really as far as I can take it, and now you've gotten all 3 different versions of straight lines written out. I hope that helps.